Hello, everyone. We come to section 2.3, limitation on linear cost model. In the 2.2, we did talk about piecewise functions. So in these sections, we come back to the cost model or the cost functions. As you know, cost function before was a linear function, but in these sections, we can seize a case that cost function become a piecewise defined function. Yeah. All right, and I told you sometime about price, about revenue functions, mostly is in quadratic form, right? However, there is a special case when the prime function is a constant, right? Like you have a fixed price and never change. And let's say in your business, you want the item gonna be a fixed price, and you don't want to change. No on sale, nothing else, just that price forever, something like that. And in that case, the revenues will be a linear function. Okay, it will be a linear function. That's good. And the reason was because the revenues will be the number of items sold time with the price per unit. So you can see that it will be just a um, a constant multiplied by x, because the constant number was the price. So like I say, I write in here as p of x equal to a constant, right? So then you you will come up with revenues equal to p of x time with x, which actually can be rewritten as c time with x. All right. So now we come to an examples 2.5 and see if we have a linear revenue function. Okay, so Lavender Laundromat is a neighborhood laundromat. Lavender has 15 washing machine, all right, 10 dryers. Okay, so let's highlight those. 10 dryers and handlers, about 100 customers per day. Okay, so I would like to highlight this. All right, so these columns talking about per day. Okay, talking about per day units. All right, and the fixed cost to run the store. Okay, so I'm gonna use green one. Fixed cost will be $65 per day. Okay, so every day I pay $65 and I will get 100 customer per day. What else do I have to pay? It's supposed to be the variable cost or the per item cost, right? So let's see. I have this include the costs such as rent, cleaning, attendant, and the cost of the electricity to power the light at night. Okay, so Zoho has a fixed cost, right? Now let's come to the per customer cost. And it's going to be $1 50 cents. So that means every one customer coming into the store, you had to use $1.50 to pay for the water, to run a load of wash. You had to pay for electricity to power the washing machine and dryer and machine maintenance. All right. So that means we have what? We have fixed cost. That's going to be $65. Okay. And we have V as a per diem cost, which is $1.50. All right. So the total cost to run the laundromat is in formats F plus Vx, which can write as 65 plus with 1.50x. Okay. Now we are having the call function. Okay. So we will come up with C of hundreds. Keep in mind that we are having hundreds customer per day. So let's count how much does it cost for 100 customer. So we're gonna using the function of cost here, and I change the x to be hundreds. Okay, so this gives me as 65 plus with 150, and that's give us as 115 dollar. So that means we have to pay 215 every day. We have to pay total cost to $15 per day. Okay. What else? What is the cost if find a customer coming on Wednesday? All right. So according to the formulas of the cost, I will to change the x to be find us. Okay. And I gotta use calculators to get I end up 15. Okay, so it's look like I'm gonna get I end up $15 on Wednesday. All right, but is that real? All right, but is it real? So keep in mind this. Do we have, I mean, do we have, is there an upper bound to the value of x, right? Think about as a business, your max capacities for a day could be like hundreds customer. You can serve maximum is hundreds customer only, right? So I will say yes. No, I would say like we can serve maximum hundreds customer. All right. So X max per day, right? Yes, small. Make it red. Okay. We can serve maximum is 100 customer per day. So suppose that the owner level can move to the larger space next door, right? So after figure out that, oh, look like I need to extend my business, right? So I need to rent the largest space next door to buy more washer. Okay, so move to the largest space next door and buy more washer and dryer. So because of that, the fixed cost will be increased and now change to be $250 per day. So this is new fixed cost, right? And I would say F2 is 240. Okay. But the variable cost, what about the variable cost? The per customer cost, is that change? Right? So think about per customer cost doesn't change, right? Because you just only extend the you just only extend the larger space, so you pay for rent, and you extend, you just buy more washer and dryer for 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 serving more people. But for customer, per customer, the cost doesn't change, and it's still gonna be 1.50, right? So V will still be 1.50. So that means that my cost functions in the new business will be F2 plus with VX, which gonna be $240, adding with 150x. Okay, so I'd like to highlight this guy because okay, and think about if I still, if I extend to be a larger space, but my the amount of customer didn't change, and still going to be just hundreds people coming on maybe say Thursday. So how much total cost I have to pay with the larger space going to be? I have to change. I have to use a second function and change the x to be hundreds, and now will be 240 adding with 150, and now it become $390. Okay, so compared to the cost in the in the case that you have an extend, this one is much higher than that's cost, right? Because you see it's worth just $215 for the let's see, for the first case when you don't when you have an extend, but after that you pay $390 if you still have the same amount of customer after you open I mean after you extend larger space. All right, so So we compare the cost with 100 customer in two space. Small space is 215, and large space is 390. All right. So if only customer come in daily, how much is owner losing by using the larger space? You can use the new cost, subtract for the original cost, which we're gonna be C200 minus for C. No, actually, gonna write as $390 and minus for 215, and that will be $175. So if it means that if you decide to extend your business, you should make sure that your customer must must be more than hundreds people coming. So you may figure out there is the K to make the cost become similar with the K you just use at before. But for right now, it's just still gonna be always losing $175. Okay. Okay, now the owner needs to get that the owner needs to get more customer into the new store. So in order to increase the revenue, this is the main thing that we want as the businessman, right? So you want to increase the revenues and also increase the profit, right? And and the capacities in the larger space now will be 200 people. So today, this yeah. So now X become X become 200 customer price. Okay. So in this case, the cost function can be presented as a piecewise function, and now I'm gonna write it down by combine the two cases that we've had before. What is the first case was original cost without extend, and the second one gonna be the cost function with extend, and I need to have the requirement for the first one, which is when demand is in between 0 and 100. For the case that you extend the business, you must have more than 100 people and less than or equal to 200 customer per day. All right. Now I'm going to draw the cost function on the graph. Okay. So you can start with you can using Desmos. Let's say we can using Desmos with C of x will be equal to 65 plus 1.5x, and then using the curly brackets at the requirement, 0 less than or equal to x, and then less than or equal to hundreds. And the second one could be like another C of x with 240 plus with 150 x. So make a requirement that's hundreds less than x less than or equal to 200. So so let me just copy this one, put down here. Yeah, and this guy. Next one will be this. Right, 240. Right? All right, so now the graph look not really nice. Let's change that, right? So we will have to change the cost, maybe as an x will be in between 0 to 200 only, because we need maximum is up to 200. But the y values, I need to know what is the maximum cost can be for 200 people. So I can actually use a 0 to some thousand, let's say 1,000 hundreds. So as you can see now, we have the p-square function of cost. Right? So if I say C of hundreds, look like it's not a P right now. Okay. Maybe I may use it to here. C of hundreds. All right. So we're gonna have the costs for hundreds people are going to be $215 here. Yep. And for the people, let's say C 2x, no, that's x 200 here. It's going to be $540 paying for 200 people. All right, so so you can grab is by Desmos. You can grab it by using Desmos. Where is that? Or using T table with value as below. So we can have X, CLX. And then for X, for CLX, I will start with 0. I know that's the cost, the fixed cost for the first one going to be the fixed cost, the first one going to be $65. Okay, and then the maximum capacity is, well, X is going to be 100, so I'm going to put down 100 there, and it's going to be 200 something, right? 214, 215. So I'm going to put down like 215. Okay, and for the second one, I may also make another tables and say like C2, C2X, and I also do hundreds, but that will not be a value on the graph. I know that's gonna be what is that? 400, 390. That's the last pay here, right? So it's gonna be 390. Let's make a hole on the graph. Okay, because in the requirement for the second one, we and the last value will be, say, 200 and 540. Yeah. So you can use that way to find the point on the graph, right? And then you can just connect those points together. Okay. So let me draw this for you. Okay. Right. Okay, so that's gonna be it for this one. And you see that this one will be for X in between 0 and 100. And the second one will be X in between 100 and 200, but not includes 100. All right. So on average, each customer spend like $500 each time. So so the price right now we approximately become just $5, right? $5 for each customer, right? So that mean if you POX, if you're using the function, if you're using you find the revenue function, we're gonna be price time with demand. right now it's going to be 5 times wage X, because price right now is a just a fixed constant number, and that means in this case we will have a linear function, right? So see, yeah. Okay. So I'm gonna highlight this guy to make sure. Okay. So now instead of a parallax, I will have a linear or a line graph. And I'm gonna graph both of those on the same same coordinate, same graph here. So as you see that I have the dashed line is the revenue. I have X equal to 5X, right? And the next one is a cost function as a piecewise function, right? So question, what is the profit if 140 customer use the large laundromat on a given day? Okay, so if you by graphically, if you look at the graph, right? Look at X equal to 140, right? So at X equal to 140 here, we can draw a line from the cost function vertically up to the revenue function. So we can draw a vertical line, go from cost function to revenue function, right? And estimate the distance the distance of this line segment is the profit, right? Okay, so how can we find the profit by algebraically? We can say big P at 150, right? 40, I mean. Okay. Will be, keep in mind that profit is what? Profit is always equal to revenues minus the cost, right? So I will write up here, profits using the color will be equal to revenues at 140 minus cost at 140, right? So what is the revenue as 140? You substitute it, right? Let's substitute. We have 5 times with 140. And then in minus with the cost. Cost at 140, how can you find that? You're gonna using the second function of the cost, which is 240 add with 1.5 times with 140. So that's, and then you end up with profits of 140s will be equal to the 700 minus 450. So that's going to be equal to 250. Yeah, so I will say 250. Yeah, so I'm going to write in here as down here. 250. As you, if you try to use graphing method and try to see the distance of this line segment, it's going to be how many boxes here, how many units here? 1, 2, 3, 4, 5, right? Each unit is 50. So 5 times 5 going to 5 times 50 going to be $250. That's true. That's correct. Okay. What if what is the profit if 100 customer use use the small laundry on a given day? So right now I come back with only 100 customer, right, as in the small laundry. So this case is the case that we haven't extend the store net. Okay, so we calculate that. I know we haven't calculated the profit, but we calculate costing. Okay. So I will use the, let's say, blue one. Okay. Add hundreds here, right? I draw the line from the cost here. Go up to the revenues. And I noted that how many units? 1, 2, 3, 4, 5, 6. Let me do count one more time. 1, 2, 3, 4, 5, 6. Look like we have 6 units there. So which means 6 times 50 gonna be about like $300 for the profit. I think so, but that is just by eyes. Okay. So how can we count? By algebra. So let's calculate P of hundreds. We're gonna be using revenues of hundreds minus for the cost of hundreds. Keep in mind that this one's supposed to be like cost in the second pieces, okay, but this one is in the first pieces. Okay, so I will substitute. So revenues in hundreds going to be 5 times hundreds, right? Because we have 5 times x now is hundreds, and then minus for the cost in hundreds. So it's going to be fixed cost was hundreds, no, 65, I mean, and then plus with 1.5 time with hundreds. I think we count that, but let's check. Let me check. It was it was $215, right? So yeah, so I will have this at P of hundreds be equal to 500 minus 215. So that's gonna give us revenue is 200. Profit gonna be $285. Okay. So let me highlight something. This guy over here. This guy over here. So what happened? Compare between the case that when I have an open, when I have an extend, I can still earn, I can still earn the store and still earn profit higher, higher profit. Or profit higher than the case extend. The case that's using the larger laundromat with 140 customer. So it's a small laundromat and higher profit. With hundreds customer. Yeah. So as you can see, according to this, the small laundrette can still earn higher profit with 100 customer than the case using the large laundromat with 140 customer. All right. So the owner want to make at least, so keep in mind that we want to make at least as much profit in the large space as we did it for hundreds customer, right? Or even they want to have more, right? Nobody wants just, you know, just as a small space. If it's just as a small space, I would not extend the business. I'm just gonna stay as before, right? So the question is, say, how many customer you need to come to that space for that to happen, right? So let's say profit for hundreds customer in small laundromat is $285, right? Um, so uh, therefore, we want the new profit function. We want revenue function minus for the cost function, or for the cost function in the new business, in the extend business, right? And larger laundromat is also equal to 285. So yes, so I will go ahead and substitute this. Revenues gonna be 5x, and then minus for the functions of function of cost in extent or in larger laundromat, gonna be 240 plus with 1.5x. That's equal to 285. Yeah, 5x, I'm gonna subtract with 240 and subtract with 1.5x. And I got 285. Simplify in the left, I will get 3.5x and minus for 240. I got 285. Okay. And now I can have adding 240 both sides. I got 3.5x equal to 525. Lastly, I will divide both sides by 3.5. 525 divided by 3.5 is going to be that's going to be equal to 150. Let's say hence. And now I will make conclusions. Therefore, we need at least 150 customer come to the larger space, yeah, to get the same profit as small space with 100 customer. All right. So if you make more to get the simple fit greater, I can say greater than or equal to fit S small space fit S small space with underscore. Yeah, I should say that better, right? Okay. So finish this. I finished this poems, all right? We can refer to section 2.311, the laundromat PDF in Canvas for a small tutorial on these examples. I will provide you the Desmos materials for doing lavender laundromas in Canvas, and you can from there doing a poems with I mean you can redraw regraph these poems and submit your picture to the canvas to share with the other. All right, I will see you in the next session. Have a good day.